right, IM2 classes. Today we are talking about the greatest common factor. We're starting our unit on factoring. Real quick, let's talk about what we mean when we say to factor something. When you factor something, what you are doing is you are taking a quantity. I'll give you an example, a simple example as a number. I told you to factor 6. What you would want to do is split it into two smaller quantities that multiply together to get the original. So it would be 2 times 3. We don't need to worry about splitting those down into ones or whatever, but 6 is 2 times 3. All right. And that's what we're going to be doing. We're going to be taking these quantities, in this case, polynomials, what we learned about last lesson. We're going to split them into two smaller quantities that multiply together to get the original. So let's look at our first example. So 9x squared minus 15. To factor this, what we're going to do is find what's called the greatest common factor. What is the largest thing that 9x squared and 15 have in common? To do this, a lot of you guys could probably do this in your head. It's just the largest number that would divide 9 and 15. I'm going to start off by factoring both 9 and 15. So 9 factors into 3 times 3. 15 would be 3 times 5. I'm going to rewrite my polynomial here. I'm going to split up the 9 as 3 times 3, and I have an x squared, minus 15 is then 3 times 5. Then I'm going to look for the largest thing they have in common. So basically, what are the numbers that both terms have in common? In this case, they share a 3 in common. Now, this one has another 3, but this term only has 1, so we only circle ones that they have in common. For everything they have in common, one of those goes on the outside, and then we're going to cross these out. Since they no longer have anything in common, I'm going to rewrite my polynomial. So there's going to be a 3 on the outside, and then it's going to be 3x squared minus 5 on the inside of parentheses. And here is that polynomial in its factored form. So let me explain what we just did. We found the GCF. So what we did is we took this quantity, 9x squared minus 15, and we split it, we factored it into 3 times 3x squared minus 5. All right. Another way to think of the factoring that we're doing here is we are undoing the distribution. All right. So if we were to distribute 3 back into the parentheses here, we would get the original. So 3 times 3x squared is 9x squared. 3 times 5 is 15. So we are undoing distribution. We're doing distribution in reverse. Right? So we're splitting the quantity into two smaller quantities that multiply together to get the top. All right, let's do another example. So 2n cubed plus n squared. So this one, it doesn't have any numbers. There's no numbers there. And actually, what I'm going to do some invisible math here. What we need to remember with the invisible math, there's a 1 in front of the n squared, and that's going to be important here in a second. So I'm going to expand the n. So n times n times n plus 1 times n times n. Now I'm going to look for what they have in common. With the variables, you can kind of see since this one has 2 n's, this one has they have total of 2 n's, and most 2 n's in common. So I can take 2n out of both of them. So on the outside, it's going to be n times n or n squared. All right. Actually, you know what? I'm going to change that just so when we're watching it, we can know where that's coming from. It's n times n. Yeah, outside we did there. Yeah. Now I'm going to rewrite things. So n times n, that's where the n squared comes from. And then 2n is left here. And then we took both ends, but remember there's that invisible 1, so that stays there. So we have now factored that. And again, we undid the distribution property. So if we were to distribute the n squared back in, n squared times 2n is 2n cubed, n squared times 1 is n squared. Right? So we are undoing the distribution property. We are splitting this quantity. the 2n cubed plus n squared, we are splitting that into two smaller quantities that multiply together to get the original. All right, so we are factoring it. Let's move ahead to trinomials. So with the trinomials, so here we have to do the same thing that we just did, but with everything. So 15, I'm just gonna, because these are kind of easy, 15 is 3 times 5. I'll go ahead and expand the b's. Plus 5 is just 5 times b. And then 10 is 2 times 5. So here, now all three things have to have the common factor, all right? So they all have a 5 that I can take out. So I'm going to take out this 5. So for every one item they all have in common, one of them goes on the outside. I'm going to take out a 5. So this has some B's, this has some B's, but no B's at the end. So we're kind of stuck there. That is nothing left in common. So my factors on this one, I have a 5, and it's 3 times 1, 2, 3, 4 B's. So B to the 4th, plus there's still a B left there, plus 2. We just took out a 5 that they all have in common. And then we're done. So we're splitting. We took a trinomial now and factored out a 5. All right, we undid distribution. We did the distribution in reverse. So if we were to distribute the 5, we would end up back with the original. So let's look at the next example here. So we have 16x squared plus 16x plus 4. So here, you can see 16. I can do a big, long factor tree on it, which would be 2 times 8, and then 2 times 4, and then 2 times 2, and factor all here. I'm going to skip that because I know 16 is just 4 times 4. And then x times x plus another 4 times 4 times x, and then 4. So here, what they all have in common, all right? So they're each a 4 in common. And so I'm going to take out a 4 outside. All right. We have 2 x's here, 1 x here, no x's over here. And so I'm going to redo things here. So there's a 4, and then it's going to be 4x squared plus just 4x. And then here, a lot of people would say, oh, we took out the 4, so there's nothing left. But here's the thing. We're undoing distribution. We need to distribute the 4 back in. If we were going to distribute the 4 back in, it would have to end up being like the original. So it's not, there's something left over, it's a 1. So 4 is 4 times 1. When we take out a 4, there's still a 1 left there. All right. So we got to include that 1. So if we were to distribute the 4 back in, that 4 shows up at the end. There's something to multiply by. So when you take everything out of a term, there's still a 1 left over there. And there we have it. That will do it for greatest common factor. Next time we'll talk about grouping. Fun times.